Okay, can you hear me correctly? Okay. So thank you for the introduction. My name is Pedro Moreno Sanchez, and I'm going to talk about credit mixing and anonymous payments for Ripple. As he said, this is a joint work with my colleague Tim Ruffin and my supervisor, Aniket Kate. So in this talk, we are going to change a little the years. Okay. No, no. Okay. Yes, okay. It's quite okay. So it's now okay or even higher? It's okay. Thank you. So yeah, now we are going to learn about credit networks. And the basic idea is that in a credit network, users represent trust between each other using IOU relations. Let's see through an example. So assume for the moment that Aniket and I trust each other for some reason, and we went for a dinner. And I forgot my credit card, and because Aniket is a nice person, he actually paid for the dinner for my part. So at that moment, I actually owed him $40. Such a situation in the real world can be represented using a directed edge from myself to Aniket with a weight of $40. But as you can imagine, we can use credit networks to represent more elaborated scenarios. So imagine that my brother Antonio comes for a visit, and he comes for a drink. It's his first time in the US, he doesn't really have dollars, so Aniket is again a nice person, and he pays for the beer, my brother. And at that moment, my brother actually owes $10 to Aniket. Antonio can settle the debt exactly in the same manner. He can directly owe credit to Aniket. But probably they're not going to see each other in a long time, probably never. So Antonio will prefer to settle his debt through the transitive trust that he has through me. In the credit network, that means that Antonio will owe me actually 10 credit, and then I will owe 10 credit more to Aniket. And in that manner, we actually settle the debt between them. So the Ripple network is actually an implementation of this concept of the credit network idea. And the idea is that in the Ripple network, we can perform path-based transactions. And these features set it apart from cryptocurrencies like Bitcoin today. Imagine that we have a network like the one depicted here, and Bob wants to perform or settle 15 credits with Caro in this case. So the first thing that Bob has to do is to find enough paths with enough credit from Bob to Caro. And once he has done that, then he has to create a transaction that has a single sender, in this case Bob, single receiver, which is Caro, and two paths. In each path is actually annotated with the amount of credit that is settled through that path. And once the transaction is signed by the sender, or the secret key of the sender, in this case Bob, the transaction is actually performed. So 10 credit is settled through the path with Eve and Dave. And finally, the last 5 credit is settled with the direct link with Caro. And in that moment, the whole credit or the whole debt is actually settled. The Ripple network has gained some importance or has flourished as an interesting alternative because the nodes in the network represents not only users, but also banks all around the world. So we have examples in Canada, we have examples here in the US, also in the UAE, in Germany, in Scotland. And these are only a few examples. There are many of them, actually. We also have examples of gateways. These are entities that allow us to integrate cryptocurrencies into the Ripple network. So in that manner, we can define the IOU relation between users in any fiat currency, Canadian dollars, pounds, or whatever. We can also define it in cryptocurrencies like Bitcoin. And even the users between each other can define their credit, their debt in any user-defined currency. So users can owe each other coffee, meals, books, or you name it. And the idea is that such a Ripple credit network allows for the first time these cross-currency transactions. Now, every 2 users can perform a transaction, even though they don't hold credit in the same denomination. And this makes Ripple an interesting alternative to improve cross-currency remittance and settlements in the world. Ripple is today the 3rd currency in the coin market cap, and it has several advantages with respect to the current banking system, as is depicted here. Nevertheless, given the success of a public blockchain in Bitcoin, the Ripple network has opted to have the same approach. So we have a publicly available Ripple ledger, in which we can see all the transactions that happen in the system, in the whole history, and all the credit links between any 2 users. As you can imagine, this raises a privacy concern that was justifiable by our work last year, in which we showed that it's possible actually to de-anonymize an important percentage of transactions in the Ripple network. And or actually figure out who is paying to whom in the actual report network. So in our work this year, we are trying to solve this problem, and we are trying to answer this question. Can we achieve some kind of anonymous payments in a report network with the features that we have in the current report network without requiring any extra functionality? So the first thought is obviously not reinvent the wheel again and try to look at the related work that has been done so far. So in our side, we have defined two different architectures to provide privacy-preserving credit networks in a provable manner. And so these two architectures have strong privacy guarantees, but the problem is that they require changes in the structure of the report network and cannot be directly deployed today in the current report network. Another alternative that we might have is the privacy-preserving cryptocurrencies that some of you may know. Some examples are Moreno, Zcash, but there are many others. The problem with them is that their functionality is based on cryptography and smart contracts that are defined for those cryptocurrencies, but we don't have them in the current report network, so we cannot use the same techniques in the current report network. So the most promising approach in terms of compatibility is Bitcoin mixing in terms of coin join. So the idea is that we have a transaction with several senders and several receivers, and only with all the senders accept the transactions, the coins are atomically sent from the senders to the receivers. In that manner, we cannot figure out which input address paid to which output address actually in this transaction. So given that, the natural thought that raised or the natural thought that we had is, what if we actually mix the paths of several transactions? And the idea that we had is that it's actually possible to mix transaction paths as long as they share a common node, like the example depicted in this figure here. As you can imagine, our goal is to hide who is paying to whom from the input wallets on the left to the output wallets on the right. And assuming that we have an adversary that can control up to n-2 input wallets in the system. So the ultimate goal is to have an atomic transaction that allows us to atomically send a fixed amount of credit, let's say 10 credits, from each of the input wallets to each of the output wallets. Okay? And the easier way would be to have a multi-input, multi-output, like a conjoint transaction in Bitcoin. However, we don't really have it in Ripple. As we saw, the only thing that we have is transactions with only one sender and only one receiver. If we use them, then we have a problem. We call it the atomicity problem. And in the example here, so imagine that A performs a transaction that pays to C prime. Because C has received already her credit in C prime, C could just disconnect from the protocol and don't pay to the rest of, don't pay in this case to A prime. So in this manner, A would have paid to somebody, but C would not have received her credit. So the payment is not actually atomic. So what we did is a protocol to actually perform atomic transactions between several senders and several receivers. And the first step that we did is define a shared wallet. Shared wallet is defined here with a circle and 3 letters, where the letters define the participants in the shared wallet. And the idea is that the signing key for the shared wallet is created with a distributed key generation. So each of the participants in the shared wallet have a share of the signing key. And now, whenever a transaction involving this shared wallet has to be accepted, each of the participants has to accept it individually, and then only then the transaction is valid. So in a sense, either every participant in the shared wallet accepts the transaction, or the transaction is not valid. Having that, it allows us to have a synchronization round. So we can have a synchronization clock between the users. So in this example, that would mean that A could pay first to the shared wallet, then B could pay to the shared wallet, and C could pay to the shared wallet. And now, only when the shared wallet has enough incoming credit, then participants could gather together and redistribute the credit to the output wallet, in this case. It means that they could redistribute it to C prime, P prime, and A prime, in this case. But as some of you might thought already, this actually doesn't solve the atomicity problem yet. And the easiest way to see an attack here would be that A first pays to the shared wallet, and then B and C just disconnect from the protocol. That means that A will have paid, but then the credit is actually locked in the output wallet, and C doesn't have a way to get it back somehow. So our protocol is actually called PathJoin and allows to perform atomic transactions. And our main idea is that we need actually only 2 shared wallets to perform that. So we need 2 rounds of synchronization. In the first one, we create the 2 shared wallets and we pre-fund them already. So imagine an example in which we want to mix 10 credits. We will first create the input share wallet and pre-fund it with 10 credits from each of the input wallets. Then we will create the output share wallet and connect it like depicted here. And we will pre-fund already each of the output wallets in the system. And this is okay because each of the output wallets can still not use the credit because there is not enough credit here, so they don't really have a path to the gateway with enough credit to perform a payment. So what we need at this moment is somehow atomically force the 3 users to fund the link between the gateway and the output share wallet. For that, we use the second synchronization round, with what we call the mixing transaction. And this transaction is a transaction with a single sender, the input share wallet, a single receiver, which is the output share wallet, and 3 paths, in which each of the paths will contribute 10 credit. And as we have seen before, this transaction is fully valid in the Ripple network, because we have only 1 sender, only 1 receiver, and several paths. So imagine that each of the paths actually contribute 10 credit. How the network will change is as follows. So first, the transaction will consume the 10 credit pre-funded in the input wallet. Then each of the input wallets will contribute 10 credit to the mixing. And finally, the output share wallet is funded with the 30 credit that we needed for our example. So at this moment, now each of the output wallets can actually perform payments to the gateway or to any other wallet connected through the gateway in the credit network. So this is the PathJoin, how we perform atomic transaction in the Ripple network. This is the main building block in our protocol. But as you can imagine, this alone doesn't suffice to have anonymous payments in the credit network. So the main problem is that we have to come up with a way to get the list of output wallets. And for that, we first require a mechanism to find participants that want to participate in our PathShuffle, in the mixing mechanism. And second, we actually need a way to construct this anonymous list of output wallets. And for that, we use a protocol that we defined this year in NDSS, and it's called DashMix. And the main idea is that each user gets the output wallet that they want to use in the protocol, and they mix it together. Such a manner they get the list of output wallets, but they don't know the link between each of the output wallets and the owner of such an output wallet. So now, as you can imagine, we take DashMix, PathJoin, put it together, and we have the full PathShuffle, which is for anonymous payments in the Ripple network. So in the last 2 minutes, I would like to discuss a couple of points. So first, we have seen that PathJoin enables atomic transactions. And even though here I have shown it in the context of privacy, it is possible to use it in other applications. So in the paper, we discussed how to use it for crowdfunding. But even in the forums, they are using for other applications. So there are many applications that could be used or could be raised using the PathJoin protocol. Second idea is the PathShuffle enables, for the first time, path mixing in the Ripple network. And we have been able actually to perform a PathShuffle transaction, a proof of concept in the current Ripple network. So it's fully compatible with the network today. And because the operations that we need is only create links and perform payments, we can use it also in other credit networks like Stellar. And finally, the last point I wanted to make is that we consider PathShuffle like a small but still a smart contract. And for that, we didn't need any script language. The only thing that we needed is a distributed key signature, and we needed a special structure of the network. So we are wondering if it's possible to perform other scriptless contract or other possible smart contracts without a script language in Ripple. And if not, which are the inner limitations that we have in order to have more smart contracts. So in the last 10 seconds, let me tell you which is the take-home message or the main ideas for our work. So we have seen that credit networks like Ripple or Stellar allow for worldwide, fast, cheap, and cross-currency transactions. However, there exist privacy breaches, privacy concerns because of the use of a public available Ripple ledger. Nevertheless, It is possible with PathJoin to perform atomic payments in the Ripple network. We have seen it, how to use it, how to leverage to have anonymous payments, but can be used for other applications. And finally, we have seen that if we combine PathJoin with DASMix, we have PathShuffle. It's a protocol for anonymous payment in the Ripple today, and it's fully compatible with the current network. And with that, I would like to thank you for your attention and answer your questions. Thank you.
We have a few minutes for questions, I think.
Just clarify, in the pre-fund stage,
Yes.
if A and B send the money and then C decides not to send his money, can A and B get the money back?
Yeah, that's a really good point.